Hey Trevin, thought you might like to see the initial steps in rebuilding your transmission and why it's a good thing you sent it. Um, so what we're going to do is we got the we're clamping our main shaft right here, up here rather, in the fixing tool in the vise, and so that's what this is. We insert the main shaft in the three-way flange. Going to slide the third gear onto it. Install the synchronizer ring and the synchronizer unit, the new one that I got for you. Install the locking plate, but don't lock down the nut yet. At that point, the third gear should spin freely. Now we're going to flip the shaft over, and we're going to measure the end play between the third speed gear and the shaft collar. And what it means by the shaft collar is this guy right here. That's what the shaft looks like. And the end play must be between 0.1 and 0.18 millimeters. Thrust washers of different thicknesses are not available. If the end play is less than 0.1, the third gear must be ground down. If the end play is more than that, the gear must be replaced. Well, due to manufacturing tolerances, believe it or not, these thrust washers are not all the same thickness. And the clearance, I meant to mention, the clearance, the end play, it's millimeters. I've got it written down here in 4 to 7 thousandths. 4 thousandths is the thickness of 2 human hairs. Redheads are thinner than that. Blondes are thinner, but that'd be a brunette or human hair. That's two human hairs. That's 3.5 thickness of 3.5 human hairs. That's the clearance, and you're supposed to maintain. So I'll give you an idea how precise this transmission is. So let's get over here. Here's the shaft in this holding fixture, which is the output flange. I'm going to install the third gear. We have our thrust washer. And these are the ones that are, this is the thrust washer that is not available in different thicknesses, except they are different thicknesses solely due to manufacturing tolerances or variations. So fortunately, I've got a variety of these, and I've picked out one that's going to work on your transmission, because the one that came out of your transmission was worn out or too thin, either from wear or because it was initially somebody at some point built it that way. Now we're going to get that lined up with our synchronizer ring. Make sure we're still on camera here. Lock this down. Or not lock it down, snug it down. Just tighten it up to where we get no slop. Pull this out. We have our flange. Put the aluminum jaws in place because we're going to be working, squeezing on, pinching down on a machine surface. Okay, now we're going to line up our dial indicator. See if we can get this to, there's no clearance here, very little room. And I'm going to rotate this around. We got a blank spot right here. It makes things a lot easier. Just hanging on there. Yep. Now I want to get 0 up here at the top, so we're going to adjust our equipment to where the needle is going to be reading 0 for ease of viewing. Okay, close enough for government work. Make sure this is stable. Okay, let's get in here closer so you see what's going on. Close up. All right. So each one of these lines is 1/1000th of an inch, or half the thickness of a human hair. And what we want to achieve is between 4 and 7/1000ths clearance. Get that on 0. And what we're going to do is simply lift up the gear. And there's our clearance. Clearance, 5/1000ths. Right on the money. It's a good thing I had a variety of brass shims. That one's 74/1000ths, 78/1000ths. Here's another one over here that I didn't use, but I had a variety of thicknesses. Again, they're all the same part number, but they're all different thicknesses due to variations in the thickness of the metal. Anyway, so by having those shims, made it where we did not have to buy a new third gear, and everything is just lining up perfectly. So I thought you might like to see the first step in that process. Now then, this poor backing plate was in really tough shape. Got a hairline crack right here due to, it looks like, the bolts or the nuts securing the flex disc to the output flange took a severe beating, because this goes in here like this, and these nuts and bolts come dangerously close to this point right there. So had a hairline crack. Also could come from people torquing down too much on this little clamp right here to secure your speedometer cable in place. Anyway, so put that little JB weld on there to keep it to help stabilize it. Got a new seal inside there, and just remember, you're not holding down the Statue of Liberty here. You're just going to clamp enough to hold the cable in place. It doesn't take much torque there to do that. Also, you can see where the flex disc was not mounted correctly, and so the bolt or the nut came across here and shaved out some material there. Also, when this arrived, this plug was not in place, so we got your new plug right there, which plugs the access to the shaft inside here for your speedometer drive. So we got a new seal in there, and everything's fabulous. And you notice how smooth this is. This thing, when we put on the back of the transmission, you could see light through here. This thing was so warped, I'm surprised it was even holding fluid. Also, another item was this input shaft, and this cone and teeth are supposed to be staked into place. The one on yours is loose. It's hard to anyway, so I'm going to substitute another shaft because this one's loose. Anyway, got that taken care of there. Got your new seal installed here and dressed down this surface, so this is flat. Got this surface dressed down, and we're gonna use the other new synchronizer hub. So we got you going.